Hello, Rebels. In today's demo, we will continue our exploration of chatMCP. We will go from the chatMCP client to the MCP server, demonstrating how both components interact with each other seamlessly. Today, we will chat with LinkedIn API using MCP Server, a powerful tool that converts OpenAPI specifications into a fully functional MCP server without requiring a single line of code. Let's start by setting up the MCP server as easily as just starting the server process from the Swagger aspects. Now, let's move on to the chatMCP client to show you how to connect the MCP server and initiate a chat session. As easy as adding a WhatsApp contact and starting a conversation with an agent on LinkedIn. Here we capture the basic information about MCP server, including the URL of the MCP server. Observe that I am not providing any credentials, API keys, or auth tokens, or any other sensitive information. This is because the MCP server is designed to handle authentication securely in the server-side configuration. This means that MCP server will manage the security aspect of the API interactions, including authentication, without exposing sensitive information to the chatMCP client. If we go to the MCP server, we can check what tools are available for use. Let's start a chat session with MCP server. The chatMCP client will initiate a conversation with the MCP server, which will then route the messages to the LinkedIn API for processing. Here you can see that both the MCP server and the chatMCP client are working together to facilitate the conversation. In this case, the LinkedIn API is rejecting the request because it requires a valid access token for authentication. This is a common scenario in API interactions and automatically handled by the MCP server. Let's complete the authentication process by providing the necessary credentials. Importantly, the chatMCP does not need to know about the authentication details. It simply sends the messages to the MCP server. The authentication is managed by the LinkedIn API and the MCP server. We can review the details of the messages exchanged between the MCP client and the MCP server, including the request and the response details. This integration in my local environment connects to Ollama's API, allowing us to interact with local LLMs. The LLM's responsibility is to infer the user's intent and determine the appropriate tool to call based on the context of the conversation. If user's intent requires a tool call, the chatMCP client will generate or request the necessary parameters and send them to the MCP server. Let's post a message on LinkedIn. If we go to the LinkedIn website, we can see that the message has been posted successfully. Here we have it. This is the message we just posted on LinkedIn. This integration demonstrates how chatMCP client and MCP server work together to facilitate interactions with external APIs, such as LinkedIn, while managing a user-friendly chat interface. Stay tuned for more updates and features in the MCP AI ecosystem. We are continuously working to enhance the capabilities of chatMCP, runMCP, and MCP Server, making it easier for developers and end users to create and manage chat applications that leverage the power of LLMs and APIs. Go Rebels!